Similar to Annalise and Alice, I looked at the effects of road salt on our environment. At the beginning of the year, we formed an essential question: how does human interaction impact our waterways, specifically the Kenduskeag stream? I formed that into my own hypothesis and came up with chloride concentrations will be higher in regions with a higher population and more impervious coverage. So, I just wanted to start by talking about how I got into the stormwater program. Dr. Stewart was really helpful in influencing me to join the program. I thought it was a great idea that kids from all over the state would come together to learn about stormwater and further create projects to combat this issue. So as you can see, I'm all bundled up with mittens, scarves, hats, layers of clothing, because to get the most accurate chloride samples, I would have to go during January, February, March, where the most snowfall occurs. And so we see that the most difficult sites that we went to during this time of year were the Penobscot River and then the dairy farm. But the easiest, which is this site, is Kenduskeag, which is site number 5. So if the first step, aside from sampling, was to look at the correlation between population density and impervious coverage. And so we see that in 2010, the population of Bangor was 32,000 roughly, while Chloride, which is the site of the dairy farm, which is site number 2, where I looked at, but we can talk about that more on another slide, has a population of 2,200 with impervious coverage of 41% in Bangor and less than 5% in Chloride, and that was taken from Maine.gov, so 2010. So if we look at the graphs, we can see that in southern Maine has a higher population density, and that directly correlates with the number of roadways we have there, and then in northern Maine, less of the population, less roadways. So that led me to do more research. So I also looked at the harmful effects of salts, and we think, why is this important? Road salt helps us, we are able to drive. The first is the effect of chloride ions in runoff. There is no natural process by which chlorides are broken down or removed from the environment. This in turn is toxic to aquatic life and impacts vegetation. The second effect of road salt is that it changes the soil chemistry. The ion exchange of sodium alters the soil by replacing and releasing nutrients into groundwater and surface water, changing the soil structure. And then the third is harmful effects on the wildlife. We see that in aquatic life, as chloride levels, they pose a risk to species survival, growth, and or reproduction. So, throughout my weeks of sampling, I mainly wanted to focus on chloride samples on both ends of the spectrum. The first is actually site 6, which is Penobscot River, and we see the bridge run right over where we sample, so I thought that would be a great place to, it would have the highest chloride concentrations. And then I looked at site 2, which is the dairy farm, and there was little interference of roadways at that site. So if we look at the graph, the red dots represent site 5 or site 6, which is the Penobscot River, and site 2, which is the dairy farm. And we can see, similar to the graphs of Annalise, that when there was a large storm, the chloride concentration would be higher, and ultimately the chloride concentrations at site 5 were higher in general. So after all the storms had passed and I stopped doing my chloride sampling specifically for this project, I came to the conclusion that my hypothesis was correct. I saw in regions with a higher population, such as Bangor, that there was a higher chloride concentration. So where do we go from here? The next step that I would take is see how we can limit the use of road salts, or also clear up these streams of chloride in different ways that we have that are faster and more efficient. For the community and ourselves, I would suggest that we limit our use of road salt and educate people more SMART and have them join the stormwater program.